All right, darling. So the next thing that you're going to be looking at is slopes. So remember, I mentioned that in class last time that slope is basically how inclined your graph is. If you think of your coordinate system, you have a horizontal line and you have a vertical line. A horizontal line goes like that. Yeah, that's not very easy to see. Okay, there you go. Here's this horizontal line. And then here's your vertical line, your x and y axes. And then in between, we have what is called the quadrant, because there are 4 of them. So this is considered the first quadrant, and that is where our x and our y are both positive. So you can think about it as an all positive quadrant. And then this one is an all negative quadrant, because you have x being in negatives and y being in negatives. So when your graph, remember we did this activity in class, we held our pencils or our rulers horizontally, and then we started rising the tip of the pencil up. Kind of, if I were to draw an arrow, think about it as a counterclockwise motion. As I increase the angle, this line right here for the graph is acquiring a slope. So from being horizontal, you can think about it, we held our pencil horizontally, pointing to the right with the tip, and then it started rising, 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 rising up to a certain degree, if you will. This kind of slope or incline is what we actually call slope in science and in math. So to determine what the slope is for a graph, you will be constructing triangles. Constructing triangles with the graph that you see. I said we are going to be making triangles. So I'm going to draw a triangle right here. So this will be my triangle, which will let me figure out the slope. When you choose those triangles, always try to make them so that they give you specific measurements. So for example, this triangle measures exactly 1 right here. And this is a very clear point because I know that y here equals 2 while x equals 1. So this side of the triangle is called rise. This is a rise of our graph. You can think about it. This is how much it rose in terms of y from 0. If my line were horizontal, it would look like this, but my graph line is actually pointing this way, so it rose a little bit. It rose exactly 2 points for y right here. That's my rise. So rise, again, equals 2. A run is this side. This is how far, you can think about it, how far did our x run? It went up by 1, or went to the right. So you can think of the triangle, any kind of triangle that looks like this, is constructed of this going up, which we call a rise, and this is where my 0 was, a run for x. So when I figure out the slope, I'm figuring out sort of like this angle here. And it doesn't have any units. It's not meters per second. It's nothing. It's just a number because I'm dealing just with numbers. So to figure out the slope, if you look at this is the wording for it. We have rise over run. In scientific terms, we call it delta y over delta x, or so a Greek person told me it's delta. But whatever, we call it delta in English. Delta is this funny triangle symbol. It's a Greek letter. So delta means change. If you look back to the graph, how much did x change? That was our run. So in other words, x started at 0 and then changed to here, and the change was exactly 1. What did y do? Well, y started at 0 and then went all the way up to 2. So that is the change in y. And again, in terms of words, it was rise for y. Delta y was rise. And run was the change in x, or delta x. Rise over run will give me slope. back to the first graph that we did, we have rise equal to, so when I figure out the slope, rise was equal to 2 and run was equal to 1. So the slope for this graph that you see in the screen is exactly 2. Now the interesting thing, and the thing that I'm asking you to comment on at the very bottom of the first page of this worksheet that you're working on, write the conclusion below. So this is where you're going to be scribbling. Once you determine the slope, you need to compare it to the factor of x. Remember, the factor is the number that it precedes x, or in other words, what number is our x multiplied by? Well, the first graph was for this, and the factor, or the number that x was multiplied by, was actually 2. Wow, isn't that a coinkydink? Slope that we found for the first graph was rise, 2, over run, 1. And it was equal to 2. What a coinkydink. Now let's look at our second graph. Here, again, if you remember, the factor in front of x was negative. And you see that our graph is not in the first quadrant. It's not in the positives. And it's not in all negatives. We have, when x is negative, y is positive. And when x is positive, y is negative. So they're opposite of each other. But regardless of where your graph is, you can always make a triangle. So I could make a triangle right here and determine the slope from this triangle. Or I could make a triangle like so, and that could be my triangle. Or I could make this triangle. You can do it any way you like. Whichever triangle is more pleasing to your eye, you can choose that one. Regardless of which one you chose, you're always going to look at what happened with your y and what happened with your x. X, if you think of the motion of x, how is x changing? It's going to the right. And now look at my scale right here. I don't know what your scale is on your graph paper, but I have 4 boxes making the distance is 2. It's between -2 and 0 is 2. Or this is also 2. It's from 0 to 2. The distance is 2. And it has 4 boxes within it. So 2 boxes would give me 1, and then 1 box would give me half of 1. So I can say that this right here is 0.5. So then my triangle that I made would have 2 for y and 0.5 for x. So how did my y change? Well, my y started at 2 and dropped all the way to 0. So this distance is 2, but if I were to look to how my y changed, I would say it ended at 0, having started at 2. So the change of y is -2. Or I can think about it as my y dropped from 2 to 0. So it will be a drop rather than a rise. And if it's a drop, then it's definitely a negative number. So it dropped by 2. What happened with x? It started at 0.5, ended at 0. Instead of rise over run is going to be drop over run. And drop is a -2. A run is 0.5. Now remember, when we divide by a decimal, I can get rid of that decimal point by multiplying both the denominator and the numerator by 10. I'm going to continue it down here. -2 over 0.5 is like 20, -20 obviously, divided by 5. Well, -20 divided by 5 is -4. So my slope for this graph, slope for graph 2, is -4. And again, if I go back to my function, to the equation, it was y equals -4. And what do you know? This number right here is the slope. Boom. So that's how you calculate the slope. One more time, I'm going to look at the next graph. I think that I will choose this triangle right here. So this triangle, my y actually rose, and my x, of course, ran again. So the run for x amounts to 2 points. And then how much did my y change? Well, it changed from 0 to 1. So it's a rise of 1. And then my slope for this graph is going to be rise over run. And it will equal, the rise is 1, the run is 2, equals half. And what do you know? Go back to the equation. Ah, wow. Boom, 1/2. I hate pink. Boom. 1/2. And then -1/4 was our last equation on the first worksheet. Well, let's see. Does our graph have that interesting slope of -1/4? As soon as I find it, we'll figure it out. There you go. Let's see. I think this triangle looks promising. So the run is 2. That's my triangle right here. And again, it's not a rise, it's a drop. And remember, if 4 boxes equal to 2, 2 divided by 4 is 0.5. So my drop for y was 0.5. Well, slope then is going to be drop over run. Drop is a negative number, -0.5. And then my run was 2. Well, then what is 0.5 divided by 2? I'm going to multiply it by 10. 5 over 20. And don't forget a minus in there. I will simplify it by 5. So it's going to be -1 over 4. And what did we expect? We actually wanted to see -1/4, and we did. So this is our slope. At the very bottom of your worksheet, I'm asking you to write the conclusion below after you have compared the slopes that you have found for each graph to the factors of x in each of those graphs. The conclusion is the slope and the factor in front of x is the same thing. And that's your conclusion. And that concludes this video.